to Unit 8, Lesson 1C. We're now going to look at some completed create tasks that have been scored so we can sort of see how the scoring happened, how it worked out. Now for some of this, you'll have to pause this video and go watch the other video because I can't really embed a video in a video. Tried that before, just didn't work. So to continue on, if you'll go to Unit 8, Lesson 1, and look for the Create PT Sample 1 video, and watch that video, and you'll see what was recorded there, what you're expected to record, okay? So again, go ahead and watch that video. Pause this one, and then come back. You're back. Now, you want to access the Create Performance Task Sample 1 written response. This is where this student has written their responses. And we're going to go over the scoring. So if you need to, pause the video and then bring this up either on your computer and you can listen as I walk through it, or you can go through it yourself, your choice. All right, for the first part, it says provide a written response that describes the overall purpose of the program. The purpose of the Word Game Helper app is to assist users in finding words to help in various games like Scrabble and crossword puzzles. Boom. Simple, short, to the point. The next part says to describe what functionality the video illustrates. The video shows how the user selects the length of the word and the first letter from different drop-downs. Again, short, sweet, to the point. Third item, describe the input and output of the program. The user inputs a value to the program using the drop-downs. What they input, how they input it. The output, which is a list of words that meet the chosen conditions, is displayed on the screen. What is the output and how is it displayed? Okay. Notice you have up to 150 words. It doesn't have to get to 150 words. You don't have to maximize it. That is the maximum. Fewer words saying what needs to be said is preferable. Next up, 3B. Capture and paste 2 program code segments you developed during the administration of this task, which contain a list or other collection type being used to manage complexity in your program. The first program code segment must show how data has been stored in the list. Okay, you declare var word list and you get column words word. You've shown how you've initialized it. How is it being stored? The second program code segment must show how the data in the same list is being processed, such as creating new data from existing data or accessing multiple elements in a list as part of fulfilling the program's purpose. Here you have filter, and you've got this waiting image. Filtered word list is empty. You set your output, your text, you set your text output to output. Then you're going to loop through your word list. Notice here's word list. You're looping through it one item at a time. And if the length is equal to the input length and the word list, the first letter is the same as the letter requested by the user, then it's added to the filtered word list. Okay. If word list.length is 0, then there's no options available. It means there's nothing that's that long that starts with that letter. Okay, and then it is output onto the screen. So here is the function. Notice it's just the function that you've already written, that you've tested and works. Now, responding to it identifies the name of the list being processed in the response. On line 1, it is so helpful, tell what line something is on. On line 1, a list called word list collects all the words from the words database and stores them as a list. Each word is stored as a string. Notice that you have fulfilled all the pieces of information in a very short sentence. You've told me where, you've told me the name of this list, You told me where it came from. You told me that you're storing it as a list and that each word is a string. Really important, okay? Now, identifies what the data contained in the list is representing in your program. The word list is used in the program to show users suggested words of various lengths starting with a given letter. And then an example is given. User selects a length of 2 and the letter B. The filter function is called, in which the word list is traversed. Every element that is a length of 2 and starts with a B is added to the new filtered list. This list is what is outputted to the user. So this is explaining how it's used and giving an example. Okay? And this is just so that I don't have this stuff later. Explains how the selected list manages the complexity. The word list manages complexity because it allows any number of words to be stored in the list instead of using individual variables for each word, which would then be checked one by one to see if it met the requirements. The program would extend from 32 lines long to thousands of lines long to account for all of these extra variables. If words are added or removed to the database this list pulls from, nothing will need to be changed about the code. The list allows the program to work for any number of words since the filter function will traverse the entire list no matter its length. So notice you've talked about how this allows your program to work whether you have a short list or a long list. You could have a list of words that are applicable for elementary school, middle school, high school, or college level students. Okay? If your vocabulary increases, you could have a larger list of words to draw from, and yet it would not change your program. That's managing complexity. 3C, capture and paste 2 program code segments you developed during the administration of this task that contain a student-developed procedure which implements an algorithm used in your program and call to the procedure. Okay. The first program code segment must be a student-developed procedure that defines the procedure's name and return type if necessary, contains and uses one or more parameters that have an effect on the functionality of the procedure, and implements an algorithm with sequencing, selection, and iteration. So here's the name of the function is filter. The parameters are len and letter. And then it comes down here and you've got step by step, you've got a loop, and inside the loop, you've got a selection. And here's another if statement. So this satisfies everything. Oops. Okay. Yeah. Sorry. Go on to the next one. The second program code segment must show where the student developed procedure is being called in your program. Here, filter, I'm calling it. Get number from the length drop down, get text from the letter drop down, and I'm converting it to lowercase. That way it's always lowercase. Okay. You want to always make sure that whatever letter, if I put in a capital A, you just drop it down to lowercase a so that you're checking everything with lowercase a. Then provide a written response. The filter function is necessary in order for the program to output a filtered word list to users which meets their chosen requirements. This is why it exists. Explains in detail the steps. In lines 16 and 30, important, put in those line numbers. Show and hide an image to let the user know how the program is working. Once the list has been filtered, the image is hidden. To filter the list, a for loop is used in line 20, which traverses the word list. The if statement on line 21 checks to see if the element at the index is required length with the required letter. If it does, the element is added to the filtered word list, line 22. After traversal of the list is finished and the filtered word list is empty, a string is added to let the user know there are no options available. Finally, in line 31, the filtered list is displayed. Notice it goes line by line or group of lines. That is so important to making sure that you cover everything and that you have detail enough that somebody else could recreate it and that you actually understand what's going on in your own code. 3D, provide a written response that does all 3 of the following. Okay, you need 2 different calls that cause it to go 2 different ways. So let's suppose the user selects from the drop down a length of 3 and the letter D. The second call, another example would be if the function was called with the arguments 1 and B. What happens? Well, 3 and D. The arguments passed through the filter function would be 3 and D for the parameters len and letter. In the for loop on line 21, there is an if statement which checks each element in the word list to see if it has a length of 3 and starts with the letter D. For example, when the element containing dog is examined, the conditions of length of 3, first letter D is met, and therefore the code segment inside the if statement runs and dog is added to the filtered list. The for loop continues running, checking other elements. Conditions tested by the second call. In the second case, again, the for loop on line 21 is used to traverse the word list. Each element is checked when A is examined. The conditions length of 1, first letter B, is not met. Therefore, 21 through 23 are skipped and the for loop continues to the next round. The result of each call. After the for loop finishes running, any words that had a length of 3 and started with the letter D have been added to the filtered list, which is displayed. The second one, ultimately no word is found with these conditions, and therefore the filtered list is blank until lines 26 through 28, where a string is added to let the user know that no word was found that meets those conditions. These are two different things. One displays a list, the other one says can't do it. So that's what you want to try to find, is so that you are traversing through different sections of your code, different parts of your code are running. After looking at the responses, did anything surprise you when you looked at this sample? Did you think it scored well based on what you know about the scoring guidelines? One of the things that often surprises students when I first go over this is how short the responses are. There's a fear that's built up that it must be something huge and long, and you see things like 100 words, 200, 750 words, and you start feeling like you're writing this huge paper. And for most students, it's pleasantly surprising that it's not that long. Hopefully you realize that this one scored quite well. As a matter of fact, it got all the points. If you go to the performance task annotated sample 1, this will go through, and I'm not going to read all of this to you because you can read it yourself, but look at it and say, here's the student response. Here's the row in the task, the decision rules. And then as you read through this, it will come down here and tell you that the response earned the point for this row to assist users in finding words to help in various games. Input and output are shown in the video and described in the responses as drop downs and list of words that meet the chosen conditions. So notice they highlight the parts of the response that they key on. Okay? So that one met it. This one, again, the response earned this point. The program code shows how the list is created and processed in 2 code segments. The name of the list is identified as word list, stores words that are displayed to the user. Boom. Okay, instead of using individual variables for each word, manages complexity. The list allows the program to work for any number of words since the filter function will traverse the entire list of words no matter its length. That's how it manages your complexity. Okay? Notice again down here. Now, this next one also gets the point. And again, read through it. Notice what they pick out, what they key on, okay? All of this, where it tells you the line numbers, what's happening. This is huge, okay? The response earned a point. The response explains line by line in detail how the algorithm works. And here, continues to go through 2 different calls, 2 different results. Now, the one thing to note here is, while the student earned the point, a stronger case for the requirement that each call must pass a different argument, causing a different segment of the code to execute, would be made if the code somewhere had an if-else or an if-else-if statement. Those are good ones to make it go through 2 different branches quickly. This one does go through 2 branches, but it's not an if-else-if. It happens at the end of the loop. So it can be a little bit tricky there. This is just when you're writing yours, if you have an if-else-if, that can be a great one to use for showing two different paths through your code. Now, we should look at some that did not score as well. As you review these, can you see the difference that caused lower scores? First thing, pause this video and you're going to go and watch the maybe and the random dog picker. Okay, so pause and go watch those two videos. Okay, you're back. Now, go to the Create Performance Task Annotated Sample 2 and Create Performance Task Written Response Sample 2. Really, more than this response sample, you can just go to the annotated because it actually pulls it in, takes all of this, and it puts it with the scoring rubric. Same thing over here. But if you want to see it fully written out, you can. What I want you to do is look at these samples. You can pick which one to look at first. And as you review this task, ask yourself, where and how specifically did this fall short? Was there one major problem that caused ripple effects through the scoring? Or were there several smaller issues? Try to determine specific aspects of the scoring guidelines or submission requirements. Put yourself in the scorer's position. Okay? Now, go ahead and do that. Pause the video. Take about 10 minutes and look through those. Okay? Now, in written response 3B, you will need to state how the named list manages complexity. And this can be tricky. You will need to make sure that you specifically speak to how parts of your program would be different without the list. Don't just say it manages complexity. Describe how. How would your program be more complex without this list? Okay, so now go back to Create Performance Task Annotated Sample 2. How could you rewrite Response 3B in order to earn the point? The problem is the code is great, the response is not great. Try rewriting it. Pause the video and do this now. Okay. The answers list, now this is a way to rewrite it. The answers list manages complexity because without it, each element would need to be stored in its own variable, which would increase the length of the code and opportunities for error. The variables would need to be carefully named to indicate if they were positive, neutral, or negative, as this is how the program determines what icons to display. For example, one variable might be called positive 0 and store the value yes, absolutely. Okay. So again, a lot of it manages complexity. It would increase the lines of code, increase opportunities for error. And what would happen? You would have to have many more variables, right? Now, as a wrap up, next time we're going to look at making a plan and how to use your survival guide to keep you on track throughout this project. You are almost ready to start. Before next class, please go back over the directions that you've got, review the 3 samples we looked at in class, think about what you might like to create and how you would make sure that you have all the pieces in place. Okay? See you next class.